Let's begin lesson 96 with review on material from lesson 94. Remember, in lesson 94 we learned to add terms that were like. Like terms are terms that may be combined. Same terms is another way we could put it. Recognizing that I have a 3m, a 2b, negative 2b, a negative 1b, and then I got these terms, let's say yellow, that don't have a variable, and therefore just a number, value would never change. We call it a constant, right? Combine your greens, your reds, and your yellows. Nothing to combine in green. Let's use green for green. What can I combine in red? B's. Negative 2 minus another 1, negative 3b. And my constants come out to plus 10. Are we feeling okay about that? Okay, now in that's just an algebraic phrase. There's no equal sign. It's not an equation. Just showing that we can recognize which terms can be combined and then doing it. We're going to take that one step further, though, now. We've got multiple terms, and it's in an equation, like so. Right? I see terms can be combined. They are like, but there's an equal sign. For this first problem, we don't have x's on both sides like we learned last lesson. We can focus, first of all, on simply adding like terms when we need to in solving an equation, and eventually getting x by itself. So first, before you even start trying to operate, recognize I have some like terms. 4 plus 3 minus 2 is 5x. Still plus 2, don't lose your 2, equaling 12. Why could I not combine the constants? Well, of course, there is this equal sign here, and it's dividing everything for now. Let's change that. But to get rid of that 2, we actually are going to have to use the opposite. Turn it into 5x plus 0. It can show it if we want to, which is going to drop off. Oh, let's not do that. Let's show it like this. Drops off, doesn't it? And now we have 10. 12 minus 2. Going to come out nice and even. Instead of dividing by 5, just for fun, let's show it as multiplying by 1/5. Same thing. Different way to show it. If you like moving horizontally a little bit here and there. This becomes a 2 and a 1. This will cancel out with the 1 that's implied beneath the 10. Meanwhile, I have a 5 being canceled and 1's being canceled. Final answer, 1x, which we can ignore, equaling 2. Positive 2. That's the one that you'll find on 298, 292, opening our lesson. Now they introduce same thing, but what we had learned in 95. So combining 94 with 95, multiple terms in an equation. If you'd like to visualize, what are my like terms? What are my like terms? All the way even past the equal sign. Do I have constants, or do I even have other variables? In this case, just other constants. Now combine 3 minus 1 minus 4. 3 minus 1 is 2. 2 minus 4 is negative 2x. Still minus 3. Don't lose it. 5 minus 2 is 3x. Don't forget your positive 12. What do I do next in eventually, hopefully, solving for x? We want to get x's to one side. I'm a fan of removing negative x's. I can add 2x to this side to make the x's go away. I can also subtract 3x's from this side, which will result in a negative amount of x's over here. I'm going to show you plus 2x. That turns this into 0x's, which is going to drop off. Meanwhile, I still have the opposite of 3 over here. I can't forget to add 2x to this side too, resulting in 5 total x's, and still the 12. Like I said, drops off. I have a negative 3 over here. Let's get the 12 now gone. Negative 15 equals 5x. Final step. Divide by 5 so that I only have 1x over here. Negative 15 divided by 5 stays negative, reduces to 3. Show me work with your answers, both practice problems. Problem set 96 is due Tuesday. Thank you.